Hello everyone, my name is Himanshu Patil, roll number 3117036, and my group consists of Sharik, Bhupesh and Mustafa. Our problem statement is evaluate performance enhancement of parallel quicksort algorithm. We are parallelizing the quicksort algorithm using MPI, that is message passing interface, to sort data by sharing the partitions generated from regular sampling. The evaluation is based on comparison of simple sequential sorting algorithm and parallel sorting algorithm. Now let's see the program. This is the generated.c file. It is used to generate random numbers, which will be fed to the quicksort algorithm. We have written the program in C language. The libraries used are stdio.h, stdlib.h, time.h, and mpi.h. Now, let's see the MPI init. The MPI init is used to construct all the global and internal variables. A communicator is formed around all the processes that are spawned, and unique ranks are assigned to each process. The MPI com rank, that is highlighted here, is used to return the rank of a process in a communicator. Each process inside of a communicator is assigned an incremental rank starting from 0. MPI-COM world is used to enclose all the processes in the job. MPI-W time is a function that returns the wall time elapsed. It is used to calculate the time required by the program to get executed. And lastly is the MPI finalize. It is used to clean up the MPI environment. MPI calls cannot be made after finalize.
Hello, my name is Bhupesh Rajpurohit, roll number 3117038. I will explain you the flow of generator.c program and also execution of our program. After including all the necessary packages, first we have to initialize MPI, also take their rank. Here, escape time is a variable which stores MPI W time, that is initial time or starting time of our program. After that, if my id equals to root condition is used to check whether you are root user or not. If you are root user, it will ask you to enter the number of random numbers you want to generate. After that, we open the random.txt file and store it into the variable fp, whereas w plus deletes the content of the file and create it if it doesn't exist. As runtime is used for generating a random seed so that each time different random number can be generated. This for loop is used for generating and printing n random numbers between 0 to 999. This is done so that you can analyze results easily. Due to the use of MPI, for loop can run multiple processes parallel, due to which we can generate multiple random numbers simultaneously and can write them into the file. After that, we close the file and print done. And for calculating the total time taken to execute program, we are subtracting starting time of the program from the ending time to get the total time taken by our program. And at last we use MPI finalize. First, I will run generator.c program and it will make random.txt file with n number of random numbers. As you can see, random.txt file has been made, in which you can see 6 random numbers. Then we will take random.txt as an input for sort.c program, which will sort the numbers and write in a sort.txt file. As you can see, sort.txt is created and all the numbers are sorted. Now program for sorting number will be explained by Mustafa and Sharik.
Hi, my name is Sharik Sheikh. Um, we will explain the quicksort algorithm. this file sort.c explains and demonstrates the example of quicksort using MPI programming. Initial two lines we have included studio.h and standard library.h so that we can use standard functions, and MPI.h provides functions from MPI module to implement MPI programming. Initially, we have declared few variables which we will need in the program, and we have also declared a variable status with type MPI status. So MPI status represents the status of a reception operation returned by receive operation, that is MPI RECV, non-blocking operation, wait, etc. After that, we have declared three functions, that is swap, partition, quicksort, which will be required when we will implement the algorithm quicksort. Few initializations related to MPI. First of them is MPI init. The function MPI init is used to initiate an MPI computation. After that, MPI barrier can be used to synchronize all processes in a communicator. Similarly, MPI WTime is a function that returns a floating point number of seconds representing elapsed wall clock time since some time in the past. And if we want to know how many processes are running, then we can use MPI com size function. Similarly, process rank, we can provide ranks to processes using MPI com rank function. After that, as Himanshu and Bhupesh used generator.c file to generate random.txt file which contains the input numbers. So input numbers will be just random numbers which will be input to the quicksort algorithm, and at the end we will get a sorted result, the result of sorted numbers. So in this function, we are reading the file random.txt which contains the input, and we are counting the number of lines, which means we are counting the number of inputs. Okay, so that we have some idea that how many with how many numbers are we dealing. Now after this, Mustafa will explain.
Thank you, Sharik. I'm Mustafa Hussain, 3117014. I will be explaining rest of the program, followed by Sharik again. Now we have called upon a function called as MPI bcast, which is a broadcast function, which will call the root function, so which with a process with rank root, so that the message is passed to all the commutator processes. After which we created a long array, a main array, for which we are going to print at the last. Local array, which we are going to pass through each and every single processes, and an array gatherer for gathering sorted array from each and a single local array. After that, calculating value of length of the arrays, local array, and similarly calculating remaining variables. Now we open the file again to get the input variables into the array I again. Because array I is the main array in which we are going to store all the sorted elements. After which we are going to call upon the scatter function, which will scatter the local A, that is the local array of a particular length, that is which is declared earlier. And that scatter that is how all the processes are going to get the particular values. After which we run the quicksort function, which is declared below and will be explained by Sharik, which is going to sort the array, and then we are going to call upon the remaining array values, and then we will run a quicksort array on them again. After which we call upon a function of MPI gather, we can call upon an MPI gather, but this is not called, this isn't called right now in our program. What we have done is we have directly called created a function of myID root, where every single process will send their values to the root process by using MPI send command. After which this an array gatherer will be introduced. This array gatherer, first it is localized with the value of 00 with the values of each and every single local array value, and then the local array gatherer is a 2D matrix. So each and every single matrix values will be stored. So if there are suppose 24 lines in the array in the file, and we have 6 processes, so this array gatherer will have value of 24 by 6. So all of that value will be stored in the array gatherer like this. And we will receive that value from by using MPI receive command from the MPI function, MPI include, which we have called earlier. This MPI receive will receive the send request sent from the each and every single process, and because since it's the root array root process, it will take upon all the values and gather. In this function, what we have done is we have gathered all the array values and put it into a array count. This array count will contain the sorted array values or the sorted values from the random.txt. So what we did was, first we created random.txt, then we added random. Read the lines from random.txt, and then we created an array on that random.txt. Then we sorted each and every values of that random.txt in its particular processes. Then that particular processes gather or in a gatherer array, and then each and every gatherer is then again sorted and then saved in an array count. And this array will save the particular every single value in a particular sorted form. Then that particular sorted array is then again stored in sorted array.txt. This sorted.txt then upon call again, so to print the values of the array, and that is how we close upon our function of MPI finalize. I will call upon Sharik again to explain the main functions of swap, partition, and quicksort.
Hello again. So these three are important functions. Namely, if we name them, first of them is swap, second is partition, and third is quicksort. So these three functions are being called from main function so that they can help during sorting of elements. So swap is simply swapping the elements. So for example, if there are two variables, A is equal to 7, B equal to 6, so that by calling this function with those two numbers, this function will assign the value of A as 6 and the value of B as 7. Now, let me explain the quicksort algorithm. So, quicksort algorithm basically starts with a pivot element. So, a pivot element can be considered any element from the array from the elements. So, it is a good idea to consider the median element as a pivot element. But in this example, we are going with basic idea. So we have considered an element that is the pivot element as array of high. High is basically the last element. So the last element is considered as a pivot element. After that, after considering that element as pivot element, we divide the array into two parts. Then again we select a different element as a pivot element. Similarly, we keep on dividing the array into two parts, then further two parts. That is, at that time the array will get divided into four parts. So when we reach at type one element only, so from there, basically the quicksort algorithm is a recursive algorithm and follows divide and conquer approach. So so from that one element, we again start coming from that root to initial level. And at that time, we also compare the elements, and that's how the sorting is done. Hope the example is clear and the demonstration is clear. Thank you.